Hello, sorry for the sound outside. They're building a street outside. Can't do anything about it. This is take forward of this problem, by the way, because every map around is trying to interrupt me when I try to record something really simple and fast. This is a pentagram composed of a isosceles triangle inside a square. A square is a figure with four sides that are equal, four angles that are equal. In this pentagram that's composed by this guy here, we have included the two diagonals of the square in the pentagram, and the isosceles triangle bisects the bisection of the diagonal. This means that if we call mn x, which means qm is x, qp is x, and np is x, we have that qn, which is one of the diagonals of the square, is the square root of x squared plus x squared, which is 2x squared and square root, which is the square root of 2 times x, which is also mp by symmetry of the square, which has a fourfold symmetry. Because the problem informs us that OK equals Kn, so we bisect the bisection of the diagonal. So OK is equal OJ is equal Kn, which is equal to Jm, which is equal to half of On, which is equal to half of Om, which is equal to half to a fourth of Kn. So with those informations, we came to the conclusion that OK is the square root of 2x divided by 4. So we can calculate JK, because JK is the Pythagorean triangle here. We have a 90-degree angle on the side in this vertex here. If we have that, we have both the sizes of OK and OJ. So OK squared plus OJ squared is 2 times square root of x divided by 4 squared, which gives us 4x squared divided by 16, which, when we take the square root of everything inside here, gives us x divided by 2. So JK JK is equal to x divided by 2. This same thing could be reasoned using this big triangle here, so it's reasonable that this is the result we obtain. So now we are going to analyze the triangle QPT, which is the isosceles triangle, which is similar, so it's congruent, proportional to the triangle RST, which is this one top here, which is congruent or similar to the triangle, or proportional is another word you can use, to the triangle JKT. So what do we know about these things? We know that the height of the big triangle, we can call it h, and if that's h, we have the following. Sorry about the interruption. So this means that QP and JK are proportional to each other in the same way as the age size, which is the height of the triangle, the big triangle, is proportional to the height of the smaller triangle, JKT. This means that as x is proportional to x divided by 2, just as the height of the big triangle is proportional to the height of the smaller triangle, which is let's say the mid-sized triangle, which is JKT, because we are going to call this y, and because of the way the geometry here works, this is also why. I won't explain further why, but this math means that y is equal to the height divided by 2, but uh but because of that, the height divided by 2 is equal to x divided by 4 plus x divided by 2 by the proportions inside the square, which means that h divided by 2 is equal to 3x divided by 4. So this means that h is 3x divided by 2. So this length here, this big length here, is h, which is 3x divided by 2. So now we have to discover this length h minus x, which is half of x. And we will relate this size with this size as proportional to the the base length with the height of the smaller triangle with the base length and the height of the bigger triangle. This means that h, which is the height of the big triangle, is 2x, which is the base of the big triangle, in the same way that h minus x, which is the height of the smaller triangle, is proportional to what we want to know, which is the size of the segment RS, which means that we get the following. Age times this question mark is age minus x times x. And if we do this procedure, and by that I mean we apply age being equal to 3x divided by 2 and age minus x being x divided by 2, we get the following after doing the cross multiplications here for the similarity or proportional math. We get that the size of the RS length is x divided by 3. By the way, if you did the drawing very accurately, you can also measure this length here, and you're gonna verify that this result is correct. And that's it. It just took me 4 takes this time. Bye.